This is a technology briefing on in-memory computing by Keith Nush. What is in-memory computing? In-memory computing is moving data which has traditionally been stored on hard disks into memory. When talking about databases, in-memory computing has the data stores reside in the main random access memory, or RAM, of dedicated servers rather than in complicated relational databases operating on comparatively slow disk drives. Another way of looking at it is in-memory computing means using a type of middleware software that allows one to store data in RAM across a cluster of computers and process it in parallel. RAM storage and parallel distributed processing are two fundamental pillars of in-memory computing. Looking at the diagram, the left side of this diagram shows how traditional computing accesses data in memory dedicated to the processor socket. Each circle is a processor socket, and each rectangle is the memory attached to that processor. The right side depicts in-memory computing. Notice how a pool of memory is shared between all processor sockets. This is what makes in-memory computing so powerful. From an application viewpoint, the left side of this diagram shows how traditional computing accesses information on physical spinning disks. Here an application requests data. The requested data has to be retrieved from disk before it can be acted upon. Retrieving data from disk is a very slow process. The right side depicts in-memory computing and shows how the data is moved off the physical spinning disk and into memory. Now when an application requests data, the requested data is retrieved from memory very quickly and is ready for the application to use. Spinning disks are still used for persistency and recovery, but the main access of data is in memory. Just how fast is memory when compared to physical spinning disks? Keep in mind, the farther away the data is from the processor, the longer it takes to retrieve it. In looking at this diagram, and for comparison using time measured in minutes and not the typical nanoseconds, if accessing the register circuitry on a typical CPU processor takes 1 minute, accessing memory would take 1.5 hours. To access data on disk, it would take 2 years, which is about how long the space shuttle would take to get to Pluto. In-memory computing exponentially improves performance. Why is in-memory computing important? There is more data today to analyze, and business requirements dictate the need to analyze that data in seconds, not hours. And businesses everywhere are struggling to keep up with and strategically leverage the massive amounts of data driving their organization. In-memory computing is helping businesses like retailers, banks, and utilities to quickly detect patterns, analyze massive data volumes on the fly, and perform their operations quickly. Here are two companies who use in-memory computing. Workday, the leading enterprise cloud solution for financials and HR, has approximately 1,800 customers, including a third of the Fortune 500 and a third of the Fortune 50. The company currently has about 26 million workers under management. As a SaaS solution provider, Workday uses its in-memory computing platform to process about 189 million transactions per day, with a peak about 289 million transactions per day. For comparison, Twitter does about 500 million tweets per day. Wellington Management has more than $1 trillion in client assets under management and offers a broad range of investment approaches. The firm's investment book of record, or IBOR, is a single source of truth for investor positions, exposures, valuations, and performance. This means all real-time trading transactions, all related account activity, and all related back-office activity flow through the IBOR in near real time. In addition to handling these transactions, the IBOR is a key source of analytics that support performance analysis, risk assessments, regulatory compliance, and more. In-memory computing is solving the real-time speed and massive scalability requirements resulting from digital transformation, omni-channel marketing, and the demands for real-time regulatory compliance. These complex corporate initiatives may take the form of web-scale applications, Internet of Things projects, or mobile apps. In-memory computing platforms bring together in-memory data grids, in-memory databases, and streaming analytics into a single unified platform that helps reduce development and operational costs through standardization on a common computing platform.